Pressure belts are regions of consistent atmospheric pressure found at various latitudes across the Earth. They are formed due to the combined effects of the Earth's rotation, uneven heating, and air circulation patterns. These belts play a key role in global climate and weather systems. The formation of pressure belts involves the following processes. Uneven heating of the Earth's surface. The sun heats the Earth unevenly due to the curvature of the planet, with the equator receiving the most direct sunlight and the poles receiving less. At the equator, the sun's rays are more concentrated, leading to higher temperatures and the warm air rising, creating a region of low pressure. At higher latitudes, near the poles, the sun's rays are less direct, leading to cooler temperatures, causing the air to sink and form high-pressure areas. Convection currents and atmospheric circulation. The rising warm air at the equator creates a low-pressure zone known as the equatorial low or intertropical convergence zone, ITCZ. As air rises, it moves towards the poles, where it cools and sinks, forming high-pressure systems at about 30 degrees north and south latitudes, known as the subtropical highs. As the air moves from the poles toward the equator, it is deflected by the Earth's rotation, leading to the formation of specific wind patterns. These patterns create distinct pressure zones. Trade winds from the subtropical high-pressure areas, 30 degrees, move towards the equator, creating an area of low pressure at the equator. Westerlies, winds from the high-pressure areas, 30 degrees to 60 degrees, move towards the poles, creating a low-pressure zone at 60 degrees latitude, subpolar low. Polar easterlies, cold winds from the poles move toward the lower latitudes, creating high pressure at the poles and low pressure at 60 degrees. Coriolis effect. The Coriolis effect, caused by the Earth's rotation, influences the movement of air in these pressure zones. It causes moving air to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere, contributing to the formation of distinct wind patterns and pressure systems. Types of pressure belts. Equatorial low, ITCZ. Located around the equator, 0 degrees latitude, this region is characterized by low pressure caused by intense solar heating, which leads to rising air and frequent cloud formation. This zone is associated with heavy rainfall and tropical climates. Subtropical highs, 30 degrees north and 30 degrees south. These are high-pressure zones found at about 30 degrees north and south of the equator. The air that rises at the equator cools and sinks at these latitudes, creating areas of high pressure. These regions are generally dry and are associated with deserts, example the Sahara Desert. Subpolar lows, 60 degrees north and 60 degrees south. At around 60 degrees north and south, there are low-pressure zones where the westerlies meet the polar easterlies. This convergence creates low pressure and is often associated with stormy and wet conditions. Polar highs, 90 degrees north and 90 degrees south. At the poles, the air is cold and dense, leading to high pressure. The cold air sinks, creating areas of high pressure over the polar regions. These areas are extremely cold and dry. Summary of the main pressure belts. Equatorial low, ITCZ, located around the equator, characterized by low pressure due to rising warm air. Subtropical highs, found around 30 degrees north and south, where the air sinks, leading to dry, high-pressure conditions. Subpolar lows, located around 60 degrees north and south, where air from the poles meets air from the subtropics, leading to low-pressure zones and often stormy conditions. Polar highs, found at the poles, 90 degrees north and 90 degrees south, where cold, dense air leads to high pressure. Importance of pressure belts. Pressure belts control wind patterns, which in turn influence climate, precipitation, and weather. For example, trade winds from the subtropical highs bring dry conditions to tropical areas. Westerlies from the subtropical highs influence the temperate climates of regions like Europe and North America. The subpolar lows bring wet, stormy weather to regions near 60 degrees latitude. The polar highs result in cold, dry conditions at the poles. These pressure belts are crucial for understanding the global circulation of air and the distribution of climate zones on Earth.